My presentation is called Passive Asset Passive Asset Detection System, and my name is Matt Shelton. During this presentation, I'm going to talk about who I am, why I wrote Passive Asset Detection System, what exactly it is, how it works, and then I'd like to talk a little bit about the future and where I see PADS going. And in the end, I'd like to give a brief demonstration and take over some questions. So I would like to, before we start anything, kind of give a brief definition of asset data. I use that, and I don't know if everyone really has the same definition as I do, but basically asset data is a set of characteristics describing a network host, and this can be an open port, a service running on it, an operating system, whatever. It's just something that describes a network host. So like I said, my name is Matt Shelton, and I'm a security engineer for a managed security services provider. My day job, basically, I manage security devices for our customers. I do all sorts of stuff. I mainly work with IDS data and firewalls. So since I am a security engineer, I don't really code for a living, so this is kind of an outside project. It's not affiliated with my company. They don't pay me to do this during the daytime, so I did found Passive Asset Detection Systems. I'm the creator, so if you like it, good for me. If it's bad, I guess it's my fault. So why do we need asset data? I identified quickly three things that we need it for. First of all is IDS analysis. It provides context to IDS alerts. So for example, if you see an IDS signature that's for a Microsoft IIS server and it was tripped on an Apache server, it's not always, really that applicable to the actual service. So you can easily, create better investigations with asset data. It also helps for filtering and tuning down your IDS systems. By giving some context to the alerts you're seeing, you can quickly, determine if there are false positives and filter them out. It's also important for vulnerability management. As all of you probably know, it's critical to know what's running on your network and to keep it up to date and patched. So by having an accurate blueprint of what's on your network, you can keep your software better patched. It's also important for policy monitoring. For example, on your internal network, if you don't allow Telnet port 23, in your network, then something like PADS or Nmap or something is going to tell you whether or not you have those services running on your network. So now, active scanners like Nmap or Nessus or Nikto or any, there's a million out there. They have some shortcomings. For example, they're network resource intensive. Let's take Nmap. You do a scan of a host. Let's just say you scan the first 1,024 ports. You multiply that by, a whole /16 network. That's a whole lot of SYN packets, going out over the network. So you have that problem. Also, they're host intrusive. If you send, weird packets to a service, sometimes they'll crash, and obviously in the production environment, that's not good. Your active scan, it's immediately out of date. It's just a snapshot of your network at any given time. So for example, you use Nessus to scan an entire network. As soon as the scan's done, someone can stand up another vulnerable server 5 minutes later. your scan is immediately out of date. And also network access is required. So like I said, I deal a lot with IDSs, and we have IDSs monitoring networks that we don't have access to. We just have a little management network off the side of it. So even if we wanted to use InMap or some other scanner, we just wouldn't be able to do it. So now, I didn't think it was fair to talk about the shortcomings of active scanners without also talking about passive scanner shortcomings. One of the problems with my program pads, along with all other passive scanners, is the service banner has to be advertised. So if a service banner is not seen in the connection, then it's not going to identify it correctly. Another problem is encrypted services are really hard to identify. Take a Apache connection. If you wrap that up in SSL, the Apache banner is going to fly over the connection while it's encrypted. So it's really difficult to try to fingerprint something like that. And also, passive scanners can only report on what they see. So sometimes, you might have a dormant system lying around somewhere with a really old version of software. You won't see it until, it's too late. So those are some shortcomings. I wanted to talk about some of the available passive scanners currently on the market. Commercially, we have SourceFire RNA, which is Marty Reusch's company. He created that. He's the founder of Snort. It's a really good product. I haven't really seen it. I've just seen some of the marketing literature on it, and it's an appliance that you can install into your network, and it integrates really well with their sensor, their SourceFire sensor that they create. And then you have Tenable Security. Tenable Security Nevo. It's also a passive scanner. It's actually software that you can install on I think a Linux, FreeBSD, and a Windows system, and it does basically the same thing. Both of those are appear to be really good products, but they're also really expensive. So often that can limit your deployment options with those. As far as open source goes, there's POF, which it listens to traffic and will attempt to guess the operating system of what's running on that system. So, it can identify like a Windows system or a Linux system or whatever, but it doesn't characterize what kind of services are running on the network. There's also it's my understanding that there might be some other ones that are around that I'm not familiar with, but I'd love to hear about them if anyone knows of any more. So anyways, that's why I wrote Passive Asset Detection System, or PADS for short. It is hosted on passive.sourceforge.net. You can go there and check it out. It's pretty cool. For this presentation, if you go to mattshellham.com/recon2005, I have this presentation along with some source code that I'm releasing today. So if anyone's interested in that, you can go there. Basically, PADS is a intelligent network sniffer. It's based on the libpcap libraries, which TCP dump, Snort, tons of other software uses libpcap. It uses PCRE signatures to map out services. So it has its own signature language that you can use to identify what it's seeing. And it is fully open source. But so anyways, I wanted to give a little diagram here. As it says, a diagram. I thought that was kind of lame that I put that there. But so say you have a LAN, And you have all sorts of Windows file shares, and SSH servers, and mail servers, and web servers, and they're all floating in the LAN. You can take pads, put it on a box, and it will listen to the traffic on the network. And as you can see here, there could be a separate out-of-band management network right here, so you don't have to have access to the network. All you need is a promiscuous interface right here using like a network tap or a spanning port on a switch or whatever else you may use. So, actually, I'm pulling notes here. So anyways, when I started out with this thing, I had 3 goals that I wanted to achieve. The first goal is I wanted to be completely passive. Unlike Nmap or Nessus, they send out packets on the network. I didn't want this thing to send out a single packet, so it does not send anything out. It's completely passive. I also wanted it to be portable. I wanted this to be something that you could just throw onto an existing IDS sensor and go at it. All it requires is libpcap, which is on most systems, along with PCRE, which is pretty widely available. I also wanted it to be lightweight. The PADS detection engine, it will log to a CSV file. It doesn't have any pretty GUI or anything like that. It just lightweight, dumps everything out, there you go. And I wanted all correlation and post-processing to be performed outside of the application. So, for example, vulnerability mapping. PADS will tell you what version of software you're running, but as far as telling you whether that software is out of date, that can be done in other software. For example, like OSM, if any of you are familiar with that, they've integrated PADS into their release. So today, I am releasing PADS 1.2. It's the new version, new and improved. The source code is not on SourceForge yet. I hope to have that done fairly shortly. You can download the code from the URL that I gave you earlier. It's mattshelton.com/recon2005. So this new version, I wanted to be a little bit more server oriented. I wanted it to be a more standalone, have kind of like a snort, kind of here it is type feel. So that's mainly what a lot of the improvements are. I created a new tiered architecture. One of the problems I was running into with the original 1.1 series of PADS was I started dropping packets, which, it did. So I kind of took the snort approach and separated the output from the actual detection engine. So with snort, you have snort and barnyard. Now with PADS, you have PADS and PADS archiver. And I'll talk about that a little bit more later in the presentation. I've also added some configuration files. It's not real cool, but it's configuration files. Lots of settings to tweak in there if you feel so inclined. I also did a lot of internal rewrites. Throughout the life of this project, I've learned a lot about programming and a lot of what you shouldn't do when you program. So I've tried to make a really good effort on making improvements to the code that most people won't notice, but I think there will be some performance and some security benefits throughout the application. So. Now, how it works. Basically, PADS, it takes 3 different types of traffic. It takes TCP packets. It looks at the first 5 packets of a TCP session, and it runs its signature language through those, trying to capture a banner from it. You know, if you actually go into the code, you can adjust that 5 packets cap on a connection. I guess the reason why I put the 5 packet cap there was because I didn't want to get into a situation where something was never identified and it kept running the signatures through the entire connection. That would have just really killed performance. So anyways, as an example, it will tell you that you have port 22 open on this system and it's running OpenSSH 3.8.1. So that's an example. It also takes ARP packets and pulls the MAC address out of it. It will also tell you, it will try to map back the vendor code and tell you, this is a Dell Computer Corporation system. So it does that. It also will tell you what ICMP activity is going on in your network. I thought this would be useful in a situation where you have like Nessus or Nagios or HP OpenView or whatever monitoring platform you may see in the network. If they continually go out and ping all their hosts on their network, that is pretty valuable data to generate a up or down type map with. So there you go. There's also filters in pads. Basically, with what you could do is you can specify whether or not which networks you want to see in your data. Like I said earlier, I work with IDSs a lot. And one of the first criteria I judge IDSs by, well, one of the first, is the filtering language, because you can, IDS tend to generate lots of false positives, and they always need to be tuned down. So if you have a good filter language, you can really tune it down and get some valuable information out of it. So with pads, what I've done is I've allowed, the program allows you to specify which networks you want to look at traffic at. So in this example here, the application will only show you assets on your network that fall within the 192.168.0/24 network and the 10.10.10/16 network. So those are 2 examples. And the reason why you want this too is just so when you look at your report data, it doesn't show you what Google or recon.cx is running. That stuff isn't real important for internal network security. The signature language. If you take a look at these signatures here, and this isn't by any means all of them, these are just some of them that I pulled out of the signature file. But if you take a look at it, it looks an awful lot like Nmap's signature language. Nmap has a cool switch on it, -S_V, and it sends a packet out to a service and then matches the response back, which is a lot like what PADS does. So I didn't take the language, or at least Nmap's language, literal. I modified it a little bit, but it looks an awful lot like it. So you have 3 clauses. Let's look at the SSH one, for example. You have 3 clauses. The first one says what the service is. This is just a generic service like SSH or www or whatever. The second line, the v/OpenSSH, is a string that allows you to identify an application, and that $2 and $1 are variables that the regular expression will fill in. And then the last clause, the SSH dash, harder to use than its benefit. Right there, that's an actual regular expression, and it's just a generic regular expression that you can take from any PCRE installation and use. So as you can tell there's parentheses right there, and those capture the actual version. So, and as you can see in this list of signatures, there's a wide variety of what pads will match. It matches SSH, web traffic, IMAP, the SSL one there. That SSL is a little bit harder to identify, but it does identify it most of the time. But anyways, we have IMAP, BNC, RDP, all sorts of stuff there. So that's that. One of the new features in version 1.2 is a banner grabbing feature. And this will allow you to record the first 5 packets of a connection into a libpcap file. So, well, it records the first 5 packets or up until the point where it's matched by the application. And what this is useful for is when you're developing new signatures. It's just a straight libpcap file that you can run through TCP dump or snort or back through pads again. And if pads doesn't identify the service, it will dump them into this PCAP file. Then you can go back through it using TCP dump or Ethereal or whatever and try to identify a banner within the packets. Then once you've written your signature for it, you can run the PCAP file back through pads and make sure it matched correctly. So one caveat on this feature is it is resource intensive. Dumping that traffic into a file isn't the easiest thing to do. So I'd only use it for debugging purposes and for development purposes and whatnot. So. Tiered architecture, I spoke about this a little bit earlier. There are 3 separate systems, PADS, PADS Archiver, and PADS Report, and they each have different functions. PADS, obviously, I've been speaking about it. It's the detection engine. I have tried to make it so it is, it does what it's best at, which is detecting things. It can send output to the screen, to the CSV file, which I spoke about earlier, and as of 1.2, to a FIFO file, shared memory space. And I specifically, decided to use the FIFO this time around because it's super fast and it's an easy way to move data to a separate program. One of the other internal rewrites of the new version of PADS is there is all the output modules are very modular, and you can easily create a separate new instance of an output module, and if basically you can just create anything you want to output out to. So in the future, if FIFO proves to not be as good as I'd hoped, we can move to a different platform. So now, and this is new with version 1.2, we have PADS Archiver, and this is the storage engine of PADS. Its sole job is to read data from that FIFO and send it to wherever it's supposed to go. It moves data into permanent storage. So it will read from the FIFO, and currently we have 4 output modules. It's CSV, which is same as PADS, no different. It's just you get that speed benefit from it. You also now we have syslog. It'll send stuff to a syslog file or a syslog process. It will also write to a MySQL database and a PostgreSQL database. Right now, the database schemas are only so-so. It's kind of just it's just a single table schema. It's really no big deal. Maybe if those don't work out in the future, we can always change them. Just like with PADS, PADS Archiver also has a very modular output system, and writing new output plugins for it is pretty easy. So hopefully in the future we'll have more output plugins that we can write to. So, and finally we have PADS reports, and this is the report tier of the application. You know, like I said in the goals, I wanted it to be very lightweight. All correlation and analysis was done outside of the PADS application. So PADS report, just, you know, it was a quick, you know, utility to generate Nmap-like reports. And if you become familiar with the application, you can kind of tell that Nmap is kind of a theme throughout it. I really try to make this program to be a reverse Nmap, a passive version of Nmap. So there's a lot of things that are similar in the application. And right now, the only form of input it takes is CSV. To be honest with you, and unfortunately, this application hasn't changed much since the 1.1 series. But hopefully that'll change soon. It'll give you, you know, as you can see, it takes the comma-separated list of assets and turns them into this. And we, you know, just a nice little report of the IP address, the MAC address, whether or not it saw ICMP, or if it didn't, and then a list of what ports are open on it. So, you know, this one here obviously has, you know, SSH running on 22, and this one has Apache 1.3.29 running on that one. So, in this version, I've tried to make some security enhancements. The first thing I did was I implemented privilege lowering. So, as you know, as now, what will happen is whenever you run PADS, if you start it up as root, you can specify a user for it to drop down to. So as soon as it binds to the interface, it drops all of its root privileges and runs as an unprivileged account. And it just uses set UID, set EUID, and set GID and set EGID to implement this. Another improvement I made was I decided to just swallow my pride and tell myself that I just couldn't do character arrays right, and I decided to get a string library. I didn't want to worry about, you know, whether or not this string was good enough. If I was handling the string right, I wanted to move away from that and just add functionality into my program. So I reviewed several different libraries, all open source libraries, and I looked for which one was going to work for my application the best. And after looking at all of them, I decided to use the Better String library by Paul H. And you can find his the code at bstring.sourceforge.net, and it's really cool. One of the things that I really liked about it was it's very modular. You can just plug it into your source code, into a separate directory within your source code, and compile it directly into your application. So what this means is I wouldn't have to require someone to install yet another library in order to run pads. And that follows along with my goal of being portable. So the Better String library just compiles right along with pads, and it's also very easy to use, and I like it a lot, and I encourage everyone to take a look at it if you're wanting to get rid of character arrays. So now I would like to talk about some of the things that I'd like to see implemented into pads in the future. One of the things I would like to see is more protocols. Right now, like we talked about, it only does TCP, ICMP, and ARP. Really, you could add whatever protocol you want into this thing. Some of the examples here are UDP. I don't currently do anything with UDP, and obviously that's a big area that I can expand into. So you can do a lot with that traffic. I'd also like to implement more ICMP stuff into it. Destination unreachables is just something off the top of my head. But ICMP, there's all sorts of stuff that you can take away from it, and I think more of it should be implemented into this project. DHCP, that's also something that I think has a lot of opportunity to pull more information into. If it's done correctly, I would imagine you could look at TCP traffic and actually follow services as they move from DHCP address to DHCP address and whatnot. Another thing that I think would be really, really good is to implement more layer 2 traffic into the program. For example, VLAN tagging. You can map out what VLANs are running on your network. Also, CDP, Cisco Discovery Protocol. If those are still running on routers and networks, then you can implement that, and the list really just goes on and on of what you can implement. So the big thing I'd like to get implemented before the 1.3 release, whenever that comes out, is detection preprocessors. This is kind of following along the same lines as Snort's preprocessors. If any of you are familiar with Snort, Snort has the functionality to look at data, straight from the libpcap library before it gets processed. So what I would like to do is have this whole detection preprocessor list that will feed libpcap data into these preprocessors before it gets processed by pads. So what this can do is we can now have long-term analysis. So there's always going to be some services that don't advertise banners. We can perform long-term analysis on that and try to make a guess at what type of traffic it is using these preprocessors. I also think that this is where we could implement OS identification. That's like the single most asked question about pads is, when are you going to put OS identification in like POF? Everyone asks me that, and it's something that I've been very cognizant about. I've looked at several different methods of implementing that, and I think that creating detection preprocessors would be a really good opportunity to implement this functionality into the program. If we were to do something like this, you could have a preprocessor that just plugs right in, that looks at the libpcap traffic and makes guesses about what operating system is running, just like POF. So, yeah. I have a big list of stuff that I'd like to see done. So, I'd like to have a new, robust signature language. Right now, the signature language, it's like I showed you, it does what it does, and it is what it is, and it works pretty well. But I think in the future, I would like to see more functionality in it. For example, right now, PADS only looks at server connections in the application. So what I'd like to see in the future is have it also identify clients. So you could take PADS and look at what web browsers people are running on the network, or look at what versions of Windows they are using to connect to whatever. So I'd like to implement that into the signature language, have like a keyword or something that says client or server or whatever. I'd also like to add non-PCRE signatures because, as I've mentioned before, PADS has a problem of dropping data sometimes, and I think one of the reasons, there's probably lots of reasons, but one of the reasons is PCRE is just, it's intensive, it's processor intensive, and it takes a lot out of the system. So I would like to see non-PCRE signatures that can be ran quickly, that we can match, just pretty trivial services off of. So that's something I'd like to put in there. As always, I'd love to have more performance tweaks in the program. I think performance will probably always be a line item on this slide. So there's probably, you can never really get it fast enough. Proof it works. Now I'd like to have a live demonstration. So basically, I've taken PADS and I've compiled it. Can everyone see that? Okay, great. And as you can see here, we have three applications. We have PADS, PADS Archiver, and PADS Report, 3 tiers. If I run PADS here, it's pretty similar to Store or TCP dump. So what I can do is I can take PADS and I can read a libpcap data. I wanted to do like a real live demonstration with the wireless, but I decided to have a more controlled live demonstration and just create libpcap captures of what I wanted to show. So please forgive me for that. So if using the -R switch, that basically says instead of binding to an interface, we're just going to read data into the application. And I have a bunch of PCAPs already done. So this one right here is going to demonstrate ICMP. Not really that cool, but it does show you what services are running, ICMP, what have been seen to accept ICMP. So I'm going to record that. Now I'm going to run ARP, which this will display, ARP packets being sent and, pull out the MAC address from it. So as you can see, there's a lot here. And if you notice, it just prints out the IP address and the MAC address, and then it tries to make a guess at what the hardware is underneath it. So that's that. And then let's see. Now this one has TCP in it, and if we pull that out, as you can see here, we've identified some hosts. Okay, so right here, we have port 22 running on this IP address with this server service. So it's an SSH service, and it's running OpenSSH 3.9, Protocol 1.99. And that's all stuff that we pulled out of the connection. And then the next one's actually Google. So what it did is, you know, looking on port 80, this IP address, it you know, calls that, you know, www, and it is running Google's thing. And one of the other things that PADS does is it's not port specific. So if you're running a web server on, you know, port 500 or, you know, 91 or whatever, it doesn't really care about that. It will still tell you that the service running is www and it's running, you know, Apache. So it doesn't matter what port you're running, it's it'll display it anyways. So now we have let's see, you know, OpenSSH, just the same old stuff, and you know, here we have a Microsoft IIS server running. So that's that. Now, what it does, and this is just the native format of PADS. We're not even really looking at PADS Archiver right now. The assets.csv file is just a, you know, comma-separated list of things found on the network. It's a pretty raw file, and you know, that's, you know, goes along with the goal of being lightweight. I didn't want it to, you know, create fancy reports when all, you know, PADS really is supposed to do is be a detection engine. So, you know, as you can see, it just dumps everything into a big file. Now, let's look at the PADS reports tool, and this tool prepares. Well, there it goes. This tool will take that raw CSV file, and turn it into, you know, something useful, you know, a nice report that you can use. I have two switches on here. One is, you know, don't convert any IP address to a DNS name, result name, and the other option is don't convert any RFC 1918 IP address to a name. So basically, if you just don't want to convert anything, you use -n. If you don't want to convert RFC 1918, you use -p. What this is useful for is, like, you know, I said earlier, if you have a IDS installation where you don't actually have physical access to the network, the monitored network, then you don't want it to try to resolve the RFC 1918 addresses, but you do want it to resolve everything else. So that's what that's for. So I'm going to read in this file here, and we'll write it out to another file. And this will print out a report of everything running on your network, and that's how it works. So the PADS Archiver application functions very similarly, very similar to PADS. You know, it reads in a FIFO and drops out to whatever it is you want to drop it out to. One of the things that is required is with PADS Archiver, you have to use the configuration file, and there's just several options in here. Down here, you can actually specify, you know, where your FIFO file lives, you know, right here, and you can also specify, you know, your output plugins right here, CSV. There's also syslog and MySQL, and you can have as many of those running at the same time as you want. It'll just write the data out to whatever combination. So, I think that just leaves me with questions. Does anyone have any questions about it?
The bane of IDS vendors, fragmentation. How do you plan on dealing with it?
Yes. Good question. The question was the bane of IDS vendors, fragmentation. Well, right now, we're not doing anything with it, to be real honest with you. Yeah, that's a short answer. Nothing. Hopefully that's something that will get solved in the future. So, any more questions? Yes?
For the TCP headers, what fields are you analyzing and looking at?
Good question. The question was, what fields in the TCP packets is this analyzing? It analyzes the payload of the TCP packet. So basically, it kind of takes the header of the packet with the ports and all that stuff, takes what data it needs out of that to record the session, and then it actually runs the regular expressions through the TCP packet. Are there any other questions? Yes, sir.
Just wondering why you did. You said you used an Nmap link language for your signatures.
Uh-huh.
Why didn't you just use Nmap and use their signatures?
Good question. The question is Nmap. If I decided to use an Nmap-like signature, why didn't I just use Nmap signatures? And that's a really good question. And the reason why I did it was because, first of all, Nmap is an active scanner, so by its nature, it's going to work differently. And I wanted to make sure that every signature in the signature file triggered off of that traffic. So Nmap, I just couldn't be sure of that. Plus, I wanted to be sure that we could keep the amount of roles down to the bare minimum. Nmap, when it sends out packets and matches them, it connects to the service, it runs all of its analysis, and then it dumps out its results and moves to the next service. But we don't have that luxury with passive scanning. Packets are always coming in, and it always has to run those signatures through the detection engine. So I wanted to make sure that we had the bare amount of signatures, just enough to match exactly what we needed. And I wanted all of them to confirm that they were, accurately matching traffic. So I didn't want to have any bloat or overhead with it. But there is a utility floating out there, and I really need to post it to my website that will take Nmap signatures and make the slight conversions to the pad signature language. So if you want to, you can run the complete set of Nmap signatures in pads. But I didn't want to make that into the official rule base, I guess. Let me get this one.
When you receive information, do you store that information and then receive more information and make decisions, or is it just a signature, a result, and a signature, another result?
Yeah, it's just a good question. The question was, when we receive information, do we take that information, store it, and then get more information, store it, and then do analysis, or is it just receive packet, match it, receive packet? Is that correct? Okay. Right now, it just receives a packet, matches it, receives a packet, looks at it, receives a packet. It does nothing real intelligent to it. That's what I was hoping to solve with some of the pre-processor detection plugins. Did that answer your question?
Yeah, I'll talk to you after.
Okay, great. Yes?
You mentioned SourceFire and RNA.
Uh-huh.
I wondered, especially since
they're expanding the free version of Snort to give more host information so it's more accurate as an IDS. If you've given any thought to seeing if you can use paths to derive that dimension that they're incorporating? So basically, you could use paths that then populate Snort's host information. So it's a little more targeted.
Yeah, absolutely. How do I answer that question? Yeah, I mean, I'd love to see that integrated, together. And I'm kind of looking right now at ways to integrate Snort and paths better. Like for example, and this is a little bit off topic here, but for example, I want Snort and paths to share the same libpcap feed. So instead of having two open libpcap connections kind of share, have more integration. But I think a lot of the post-processing and post-correlation need to be done in tools outside of paths. I mentioned, OSM. That tool will take, different software and correlate them together and provide reports for you. And I'd like to see that kind of functionality integrated in other tools. I imagine you could probably write like detection modules for Snort to eliminate it at that level, but that's something to look into. So hope I answered your question. Are there any other questions?
Okay. Have you thought about extending the pattern matching so that instead of just matching on banners, you actually incorporate some intelligence about how layer 7 acts and pick up on application works for people that change their banners?
Yeah, that's a good question. The question was, instead of just matching banners, could pads, eventually match, characteristics of the packet and of the session? Is that correct? Like more layer 7 type stuff?
Yeah.
And I think that goes back to the detection, plugins. That I think you could write, real C code to analyze a packet and put it in this nice little module that plugs right into pads. So I think that's where that type of activity would fall. Does that make sense? All right, are there any other questions? Okay, well, thank you very much for letting me speak. I feel very honored and humbled for being able to speak in front of you today. Thank you very much.